What's that? Okay, different partner every time. Right, for those 10 generations. Each time you can be partner for the 10 generations.
Come on. Oh.
Hey, he died again. Second dead baby.
Yeah, I'll go in a second. I have 3 days. All my kids died. Like, of course. What do you mean? I'm supposed to.
Alright, so for this last case scenario, you're gonna look at 2 separate sets of data for this last one. You're gonna look at the data after 5 generations and then after 10 generations. You can see how it changed after the first 5 and the second 5, right? So we're gonna raise our hands twice. The first time, we're gonna be raising our hands for what you are right here at the F5, not the very end, right, in the middle. And then we'll do it again for the F10. So first, let's do the F5 here at the 5 generations. So let's get our big A, a big A, little a, and a little a after 5. So again, right here, we're not looking at the 10th generation, but the 5th generation. Okay? So at the F5, raise your hand if you were homozygous dominant, big A, at the F5 generation. Right, nice and high. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11.
Oh, wait.
12?
Yeah.
Okay, 12. Alright, at the F5, we should now have 14, if we did this right, who are heterozygous. So raise your hand if you were heterozygous, big A, little a. That should be 14. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. 14. And then 0, right? Homozygous recessive. Okay, now, let's look at the F10 generation now, the very end. We want to do the same thing. We want the big A, little a, and then the homozygous recessive, which should be 0. So we did this right. So how many of you were homozygous dominant at the very end, the F10? Raise your hand if you're homozygous dominant at the very end. 1, 2, 3, 4. Okay. So this should now be 22 heterozygous. Raise your hand if you were heterozygous. Should be 22. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 18, 19, 20, 21, 22. Yes. All right. So we're 22 there. Okay. So there's our data. Now again, we're going to look at this more tomorrow, but you can already start seeing, hopefully noticing some patterns here in our data. What I would like you guys to do at your tables now, based on what we were doing on the previous 2 scenarios, I want you guys to calculate the frequencies for the genotypes and then figure out P and Q for each one, just like we were doing it. You know, if you need to go back to the actual lab, this page, you can use that page to help you. But I want you to calculate the genotype frequencies, the 3 of them, and P and Q for each of these. So work together at your tables. If you're not sure, I can help you with it. Okay? Well, let's try and do that right now. 24 and plus 14. I don't think it's right. So you double the big A's and then
52. Yeah. Look at
3, 6, right?
24 plus 14 plus 14.
You double this and you got 14 too, right?
Because we did the second
And it's
part.
on 52.
Oh, I was like, wait, 24 plus 14. Why would you do the second part?
Okay, so you have 26 individuals, right? And they each have 2 alleles. So there's 52 alleles total, right? So you're dividing by 52. So when you look at this, like here, we have, which is your data? Like this, right? So you get 12s, big A, so there's 12 plus 12 is 24. plus, but then you have also these 14 here, right? So you gotta do 24 plus 14, because these count twice, and then there's one there, so you have to add those 14.
Oh, so you're counting plus one.
Right, I appreciate it.
Alright.
And then the other one, too. Okay?
It's 38.
Yes.
I got it. Yeah.
Okay, so now P and Q are basically alleles. So you have 26 wheel calculation, P and Q, raise your hand, I can't help you with that calculation, you're not sure.
So Mr. Prost,
If you're completely done with your calculations, you can go back to the lab and start working on questions.
so to get active time generation.
We're not doing case 4.
You're gonna use that, the second set of data that you put on board, that 4.20. That's how your time generations. Okay?
Oh, yeah.
See base up. Like, so you have 26 individuals, right? They each have 2 alleles, so that's 52 alleles total, right? And then for the dominants, these are, they've got 2 capital A's, so that's 12 plus 12, 4 total capital A's there. And they each have 1, so that's 14 in all. So you got 24 plus 14, that was 38. Divided by 56.
Okay. All right.